Hey guys, so equation 1 and equation 2, they want us to find the maximum height of the objects and how many seconds does it need to get to the maximum height and how many seconds does it take the rocket to hit the ground. So this is so much easier than it probably looks at first, but all you have to do is if you take a look at the second equation, remember the equations are equivalent, so they're the same equation, they just looked different, they're in a different form. If you look at the vertex form, well, it's called vertex form because it has the vertex in it, right? And just like transforming, it's 4 to the right and 5 up. That's the vertex. So 1, 2, 3, 4, and 5 up. So if this is the vertex, okay, that's going to be the top of our quadratic, right? So that means at 4 seconds, after 4 seconds, it reaches its maximum height of, I think this was in meters, 5 meters. Okay, so that was a lot easier than you probably thought you had to. Now, the reason it gives us the equations in the first one over here is because this is our roots. From here, we can tell where it equals 0. If I put positive 9 in that first parentheses, I get 0. And if I put negative 1 in the second set, I get 0. So that means negative 1 and positive 9. Any of the negative numbers we don't really need. It starts right here. Our equation starts right here. That's where the rocket, so it must have been a little bit above ground. That's why we have negative 1 seconds over here. But basically, we can already figure this out. It tells us it's in the air for 9 seconds, right? So from 0 to 9, this object over here is in the air for 9 seconds. So I think we've answered just by maybe drawing this little graph, looking at how our equations are written. We've answered both of these questions. So hopefully you saw that this was a little bit easier than you thought. Answers in complete sentences always get more points with explanations. Complete sentences with explanations get more points. Okay, let's do the next one. All right, the test is going to give you 3 tables, and it's going to ask you to figure out which is quadratic, which is linear, and which is exponential. So if you look at the first table, it looks a little bit different than the rest. This is the quadratic table. And how can I tell it's quadratic? You can tell it's quadratic because your output is first it's going down, 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 smaller, smaller. Then it starts going back up. Well, it stays the same right here, and then it starts going back up. Okay, so I think the easiest way to write the equation for this table is to find our 2 zeros, right? These are where, when y is 0, this is where it's going to cross the x-axis. So if you think about it, this little one right here, it's going to cross at -2 and at +3. And what that means, I know that picture kind of popped out of nowhere, but what that means is it's going to go down first and then up, which is why it looks like this smiley face, right? Down to -2, then back up at 3. Halfway between is 0.5. That's where our maximum is going to be. But from this table, the easiest thing is going to be to write our equation as x plus 2 times x minus 3. And we can check it, remember, because -2 would make this 0 and +3 would make this 0. And you can check it by putting another number in. If we put in 0, like if we input 0, our output should be -6. So if you make x 0 here and x 0 here, you get positive 2 times negative 3, which is negative 6. So we don't have any stretching on this one. So this is a very easy way to write that equation. Look at the linear table up here. You can tell it's a linear table because our output, our f of x, is either adding or subtracting the same number each time. In this, it's subtracting 4 each time. So there's two things I can look at. One of the easiest ways, since I have, oh, I don't have my y equals 0. So actually, forget I just did that. Can I erase that? Yeah, forget I just did that. Let's just do point slope form. And you can, well, I guess we could choose, you can choose any point. We could choose the one I just did, or we can choose this point right here. Okay, and it's point slope form, the same way we did our height, which is the slope times x minus x1 plus y1, right? So any x and any y will do, and we know our slope is negative 4. So negative 4 times x minus 1, right, plus negative 3, or just minus 3 on the outside. Okay, and don't forget, if we chose another point, like let's do, I'll highlight this one was the point we chose was pink, but let's do one where our x is negative, like negative 1, 5 here, because I want you to see what happens on the inside. You get negative 4 stays the same, but this time x, we're subtracting a negative 1, and then it's plus 5. So what happens when you're subtracting that negative 1 is that it becomes x plus 1 plus 5. Okay, and remember, this is how it moves or transforms the equation, right? So it'll go to the left 1, that's what that plus 1 means, and then up 5. Okay, and then, oh, it's going to drive me nuts if I don't make this blue too. And then lastly, we know this table is exponential because you are multiplying by the same number each time. And if you're multiplying by like a number that is, any number that is bigger than or equal, not equal to, I guess, just greater than 1, it's an increasing function. And if it's anything less than or greater than or equal to 0 or less than 1, it's going to be decreasing. So any sort of fraction that's not a whole number, it's going to be decreasing. And if you remember, you have, here's our formula, 1, and it's either plus or minus our rate of change, all right, to the power of x. Or if we don't have a rate, if we just have a number like we do right here, we have y equals a, which is our starting value, times just the ratio that we're multiplying by each time to the power of x. So in this case, it's going to be y equals, what's our starting value? It's right here, where x is 0, our y-intercept is 4, so 4 is our starting value. And we're multiplying by 4 each time also to the power of x. And the important thing, I want to just highlight, this 4 represents, because they're both 4, the table 4, and then, oops, in green, this 4 is the number that we're multiplying by each time, okay? And the other important thing I'll do in pink, just say in an exponential relationship, you can tell it's exponential because the x, or the variable, is in the exponent.